everyone, welcome back to my online teaching platform. In this video, we shall learn how to differentiate any other polynomial function apart from linear function. So in this video, we have a function y is equal to x squared. So this is a quadratic function. Since the highest degree of the function is 2, so we have a quadratic function over here, and we are to find its derivative using the first principles. So let us look at how best we can differentiate the given function. So we have the function y is equal to x squared, which implies that our f of x is equal to x squared. So that's the first thing that we are supposed to do. Then we can now put down our formula which is dy dx is equal to the limit of f of x plus h minus f of x, all divided by h as h approaches 0. All right. So we need to get the component of the formula. So we already have our f of x to be the original function, which is x squared. So we now need to find our f of x plus h, which means we are just going to replace x with x plus h. So wherever you see x in the function, you replace it with x plus h. So we are going to get x plus h in bracket, replacing the x, but there is a square there, so you replace it. You just replace the x with the x plus h, then you bring back your square or the power. So you need to expand this one. So when we expand, we are going to get the first square. So it's going to be x plus h multiply another x plus h. And this will give us, so x times x will give us x squared, x times h will give us xh. Then we have x, h here also multiplying x, we are going to get xh. Then h times h will give us h squared. So at the end, we are going to get x squared, but you could say we have 2 of the xh, so it's going to be 2xh. They are like them, so plus our h squared. All right, so this becomes our f of x plus h. So we can now substitute it into the formula. So we have our dy dx to be equal to the limit of, so our f of x is now, sorry, our f of x plus h is now x squared plus 2xh plus h squared. Then minus the original function, which is x squared. All right. Then all divided by the small change in x as the h approaches 0. All right. So we continue to simplify. So we are now going to get the limit of, so you can see that here we have x squared here. So this x squared, and we have minus x squared. So this and this cancels out. Now we are left with only a limit of 2xh plus h squared, all divided by h as the h approaches 0. All right. So we need to simplify. So we are going to get a limit of, now if you have a fraction this for, let's say a plus b, all divided by c, is the same as dividing each of the component of the numerator by the denominator. It's going to be a divided by c plus b also divided by c. So that's what we are going to use here. So it's going to be 2x h divided by h, then plus h also squared divided by h as h approaches 0. So we continue to simplify. We are going to get a limit of So this h here cancel this. Here 1. Here we are left with hy. So we are going to get the limit of 2x plus h as h approaches 0. So now we can take the limit of the remaining components. So it's going to be equal to 2x. Wherever you see h, you put 0 over there. So plus 0. And that will give us 2x to be the derivative of the function y is equal to 2x. Therefore, what dy dx is equal to 2x, or you can write it as, so we are going to replace the y here with the y attached to the d with the function. So because we know y to be 2x, so, x squared, so we can write it as dx squared dx, so which is equal to 2x. All right. Thank you for watching. And do not forget to subscribe to my YouTube channel, which is Math with Ebefa. Bye bye.